Hi friends, I am Dr. G. Srinivasa Gupta, Professor, Department of Mechanical Engineering, VIGNANA JYOTHI, Institute of Engineering and Technology. Today we are on the part of Dynamics of Machinery course. We are going to discuss a small topic, pivoted block or shoe brake. Analysis of that brake, torque required to brake, that is braking torque, and also power required. So all those details we are going to discuss detail today by taking some numerical exercise also. Coming to the pivoted block or shoe brake, we know that ordinary shoe brake is rigidly attached to the lever. That is in my previous lecture also we have seen analysis of this. Rigidly attached to the lever and lever fulcrum and all other details, radius of the brake drum or okay. So this is the effort at all required to be applied to apply the brake. And if you take only block, then if it is rotating clockwise, drum is rotating clockwise, then tangential force or frictional force, okay, let us say Ft on the block acting towards right if drum is rotating clockwise, and this is pivoted at some point. Okay, we have seen different conditions when the line of action of the tangential and also normal force acting Rn on the block due to the contact of the drum. If isolate and draw the free body diagram of the drum, then we can show these forces. So then there are various cases we have seen already in this case when the line of action of this tangential force is passing through the pivot. That is one case. If line of action of tangential force is just above the pivot point, then we know that the moment about pivot point due to Ft is same direction as the effort applied, moment of effort about O. So it is supporting, helping to apply the brake. In other case, if the line of action of tangential force on the block due to drum is lower the pivot point, then there will be a opposite moment. So it is not that much effective. Okay, anyhow, these are the three cases we have seen: aligning line of action of Ft, aligning to the pivot point, that is passing through the pivot point, or some distance above or some distance below. These are three cases. Coming to the difference between block or shoe brake and pivoted block or shoe brake, means it is not rigidly attached. This is on the drum. The block is pivoted block. It means it is having on the lever. Okay, this is having. Okay, this is exactly the surface of the drum which is in contact, and because of this the pressure along the contact surface is uniform. In this case the pressure is more at the center, applying pressure, braking pressure, and it is less in ends. So in this case, how do we calculate braking torque and power required for braking? In this case, simply we need to use this relation mu. Instead of mu we are using coefficient of friction between block and drum in simple block brake. But in case of pivoted block brake, let us say mu dash is coefficient of friction, effective coefficient of friction between drum and block. Then we can write, okay, for mu dash equal to 4 mu sin theta by 2 theta plus sin 2 theta. I think you are able to, of course, if you want these terminologies as usual, this is radius of the drum and this friction force wherever you want, the total friction force, okay, or tangential force on the block and normal force total normal force Rn. So all these are terminologies here. So how do we arrive this mu dash effective coefficient of friction? So for that you want, but that is not important here, but if you apply this relation, you can find effective coefficient of friction. Or if you want to have that, how we are going to arrive this, in that case you can consider small element. This is the center of the drum, this is the block, okay, which is wrapped around the drum surface, let us say this much. Then if you take small elemental length of the block, then this is making an angle d pi with the center of the drum. Then you want this normal direction component of the force, so dfn, normal force drn, let us say. Then you know that this total angle is theta, so you can say that r d phi, normal component here we want on this element, so r d phi, okay, r d phi is the length of this element, into b is the width, let us say, that is the area of contact. Area of contact into, let us say, pressure is uniform, as we said, pressure applied at each and every point. Then this is the Rn. If you do the integration minus theta to theta, okay, then because you know that this normal force rd pi and p we have written, this is area into pressure we have written. Okay, that is normal, that is force, this is frictional force actually. Normal force we need to take this angle, let us say theta, the cos theta or cos theta. It's this force component cos theta. So drn cos theta, okay, d theta angle subtended, here d phi we have written, okay, d phi, okay, anyhow. So this is, okay, minus theta to theta, like that. You take frictional force also component here and do the integration. Then this frictional force per normal force, you can, if you write the ratio, you will arrive this relation. Mu dash is 4 mu sin theta by 2 theta plus sin 2 theta. This is all about how we are going to get derive effective coefficient of friction mu dash in case of pivot block break. So the problem, if we take any numerical exercise, then the solution is, but one more important point you need to remember here, if contact angle of this block with the drum greater than 60, because it is 60 means this is simple block break, greater than 60, then only we will go for finding effective coefficient of friction. Let us see one small numerical exercise on this. Okay, the problem procedure is as similar as block break, but only you need to take care effective coefficient of friction you need to use in all these relations. So here numerical problem on pivoted block or shoe break, contact angle is greater than 60 degrees. So here if you read the given specifications, a pivoted shoe brake act on drum of 400 mm diameter. So radius is 200 mm. The angle of contact between the shoe and the drum is 100. It is more than 60. So obviously in any numerical exercise problem, if it is greater than 60, it need not mention specially for find mu effective. You obviously you need to use directly mu dash relation only. If it is more than 60 degrees, contact angle of shoe with drum. Okay, the coefficient of friction between the lining and drum is, it is coefficient of friction general, but effective you need to find using mu dash relation, mu dash and mu relation. Mu dash is equal to mu times this angle, that is relation is already shown, this one, this relation 4 mu sin theta by 2 theta plus sin 2 theta. Here the coefficient of friction between lining and drum is 0.3 means that is mu. Okay, mu dash you need to evaluate. On the perpendicular distance of line of action of normal reaction from the pivot is 120 mm. So this is okay, let us say this is lever, pivot, and this is the block. Okay, this is normal force Rn and frictional force if drum is rotating clockwise Ft. Okay, then we will take the case line of action of this frictional force is passing through pivot, and the distance between R and this one and pivot is given as, from the pivot is 120 mm. This is 120 mm. So the distance of the friction force from the pivot is 280 mm, and first one is the line of action of the perpendicular distance of the line of action of normal reaction and the pivot is 120. This is 120, okay. And the distance of the friction force from the pivot is 280. In this case, friction force to pivot is, there is a distance. It is not passing line of action. So this is 280. Line of action of friction force, and pivot point is this one. So this is 280. I think you are able to understand. So the length of the lever is 500. So total length of the lever is 500. Okay. Okay. So this is the case we can take. This is friction force, line of action, and pivot point O, let us say, is 280 mm. Then if I take moments about pivot point, what we need to find, first of all, let us see. Effort required at the end of the lever. What is the effort required here? If you apply end of the lever P, what is that effort required? You need to find. Okay. And apply the braking effort required at the end of the lever to apply the braking torque. Okay, and assume the normal reaction between the block and drum is 1500. Normal reaction also given. This normal reaction also given. Okay, this is the block, let us say. Okay, normal reaction also given. This normal Rn is also given, and this is, okay, mu dash Rn Ft in this case pivoted block brake, and this distance is given, pivot and frictional line of action, this is 280 given. Okay, so this is 120 given. Of course, the diagram you need to show like this because distance is more than 120. So here you are showing large distance, and here also you need to show the distance accordingly. Okay, this is 280. Anyhow, so you need to find the effort required, P. So effort required. Okay, this distance also you know. Now take the moments about pivot point, then P into, okay, P into L. L means 500 given, in mm I am writing. Okay, this is clockwise, and then if you take F also, Ft into 280, it is also clockwise movement, that's why plus. And if you take Rn equal to Rn into 120. In this relation, P is only unknown. Okay, Rn is given, and but Ft is what? Ft is mu dash Rn. Okay, Rn is given. Mu dash you need to find. Mu dash is equal to 4 mu sin theta by 2 theta plus sin 2 theta. Okay, this relation you need to use. Okay, you need to use and find mu dash, and then use this Ft, evaluate Ft, and use that in this relation. It is, you can find P. Okay, I think you are able to understand. You can see this. Okay, this problem. Okay, it is solved, and you are going to get B is 280. Then if you take the mu dash is, you got 0.337, right? And if you take the moments, so you can see that P into L plus Ft into B equal to Rn into A. So P you will get, P is 76.9 newtons, and this is effort required. Then if you want to calculate braking torque, Ft you have already calculated. So Ft into R is the braking torque. Ft here mu dash 0.337 into 1500 newtons. So you got 505.5 newtons. Then that into radius will give braking torque required. So these are the things. And what you need to important point you need to understand in case of pivoted block brake is the angle, first of all, contact angle of block with the drum must be greater than 60 degrees. Second one is equivalent coefficient of friction you need to calculate using the relation. Then solve for equations. You can find tangential Okay, force or frictional force, it is called, or frictional resistance required, and effort required also you can find using these relations. So this is all about pivoted block brake. Okay, we will have next lecture on double block or double shoe block brake, that we will discuss in the coming lecture. So I am concluding here this lecture. Thank you one and all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.